So, hi.
Good day, sir. I am the cadet John Lemor of Dublin, and I am from the Group 3. And to start today's report, we're going to start with our topic. What are the differences between vector and raster charts? Now, before we differentiate these two, let us first know this. There are two types of electronic charts approved in the Hydrographic Office. These are the two. So the electronic navigational chart, which is government approved vector charts, so the same na sila. Next is the raster navigational chart, which is the government approved raster charts. Now let's move on. Raster charts. Raster chart data is digitized picture of a chart comprised of millions of picture elements or pixels. So all data is one layer and one format. The video display simply reproduces the picture from its digitized data file. So from this we can conclude that a raster chart is simply a digitized picture. So it is a picture that is in a file format. So it is stored in our devices, cell phones or laptops, or in this case in Ecdis. So raster charts are merely pictures, digitized pictures. So with raster data, it is difficult to change individual elements of the chart since they are not separated in data file. So this file is only serves as a picture, so it is uneditable, so it cannot be edited. Raster chart files tend to be large since a data point with associated color and intensity values must be entered for every pixel on the chart. So this definition or this explanation is very self-explanatory. Raster chart is merely a picture, a digitized picture. So on the other hand, let's move on to first is we need to discuss also the advantages of raster charts, and this can be summarized as follows. So before we move on to vector charts, let's first tackle what are the advantages of raster charts. First is user familiarity, since they use the same symbols and colors as paper charts. Yes, of course, because they are accurate, because as what I've said, they are just a digitized picture. So it is an exact copy of an exact paper chart. Next is, yes, what I've said, they are exact copies of paper charts with the same reliability and integrity, because of course they are Xerox copy, as we can say. Next is the user cannot inadvertently omit any navigational information from the display. So this happens sometimes because when we try to work on our charts, we tend to erase or omit some significant or important symbols or information on the chart. Well, in this case we cannot omit because it is a picture, so it cannot be edited, as I've said earlier. Cost of production is less than their vector counterpart. So less ra siya kay it only is a picture. It has no file, it has no layers, it's only a mere picture. So wide availability of visual raster charts. ARC's charts, for example, have near worldwide coverage. So one advantage is it is very easy to find, and it has a wide availability. Next, by using vector overlays together with appropriate software, raster charts can be used for all standard navigational tasks normally undertaken using paper charts. So with this, normally on what we do with paper charts, we can easily use we can easily do also when using vector charts, as it states, when only using the appropriate software. Lastly, or next is they can also emulate some of the functions of an electronic display and information system. Next is the disadvantages of a raster chart. So first up is the user cannot customize the display. So yes, of course, we cannot customize the display. When using vector overlays, the display may appear cluttered. They cannot be interrogated without an additional database with a common reference system. So lagi, of course, limited ra ang iyong information or iyong use because it is just a picture. It is the same with a paper chart. Next is they cannot directly provide indications or alarms to indicate a warning to the user. Unless data content is the same, more memory is required to store data compared to a vector chart. So as it was stated earlier in the explanation, that vector charts tend to be large files. So next, let's move on to vector charts. Vector chart data is data that is organized into many separate files or layers. So this is an exact opposite of what a raster chart is. So it contains graphic files and programs to produce certain symbols, points, lines, and areas with associated colors, text, and other chart elements. So from this sentences, or from this statements pa lang, we can conclude that there are many uses of vector charts, but on the other hand, we can also say that it might be too complex, so you need to be knowledgeable about using vector charts. So the programmer can change individual elements in the file and link elements to additional data. Vector files of a given area are a fraction to the size of raster files, and at the same time much more versatile. So from the word more versatile, so mas versatile siya mismo kaysa sa raster charts. Okay, of course it is consist of many separate files or layers. The navigator can selectively display vector data, adjusting the display according to his needs. So mine on that, so it can we can adjust the display. So with the raster charts, we cannot do that. Vector data supports the computation of precise distances between features and can provide warnings when hazardous situations arise. So from this explanation, we can say that it is an exact opposite of what a raster chart is. Now for its advantages and disadvantages. First advantage of a vector chart is that chart information is in layers, which allows selective display of data. So you can change, it's stated earlier. The display may be customized to suit the user. So we have each of us has different preferences when using charts or the Ecdis. So with the vector charts, it can accommodate what the user's preference is. Chart data is seamless. It is possible to zoom in without distorting the displayed data. So we can zoom in without sacrificing the image or the quality of the chart. Charted objects may be interrogated to give information to the user. So each symbol, so we can interrogate it, or like for example, we can right click so to show more information about that symbol. So it is far different, it is far opposite of what of the raster chart. Indications and alarms can be given when a hazardous situation such as crossing a safety contour occurs. Yes, objects may be shown using different symbols to those used on paper or rasters, so it can be different. So for me, that last part is, it can be an advantage or disadvantage, especially to someone, or especially to a user that is not very knowledgeable when using this kind of charts. Next, chart data may be shared with other equipment such as radar and ARPA. So because it is a file, it consists of many layers. It is not simply a picture, so it can be shared with different devices or equipments on board. Unless data content is the same, less memory is required to store data compared to a raster chart. So it is self-explanatory. It is what it is. It is a literal explanation. Next one is the disadvantages of a vector chart. First, they are technically far more complex. So, diba? This is what I said at the start. So, of course, because it has many functions, it has many factors, or there are many things you can do with the vector charts. So, for someone or for the user who is not very knowledgeable, it can be complex, it can be difficult to manage or to operate. They are more costly and take longer to produce because much complicated man siya. So it takes longer to produce and costly. So it may not take up a lot of memory compared to the raster chart, but it is more costly. Of course, it's expensive. It is natural. Worldwide coverage is unlikely to be unchanged for many years, if ever. So worldwide coverage, so dili ka siya available to different countries because it is quite expensive and costly. So maybe that's the reason. It is more difficult to ensure the quality and integrity of the displayed vector data. So yes, of course, also, so kay pwede man siya ma-change ang kuan, you can edit or you can do a lot of things. So it is difficult to ensure the quality or the integrity displayed. So if accurate pa ba siya, or it is still true, or is it is still if it is still a fact. Lastly is training in the use of vector charts is likely to be more consuming and costly compared to that the needed for raster charts. Now, I think that is all for my part of this report. I will now give the floor to my colleagues. Thank you.
And now, let's talk about the setup for Ecdis system. First, let's talk about the importance of Ecdis. Ecdis failures in the setup procedures and the use of Ecdis safety settings and alarm systems have led to a number of groundings, just like CSL Thames, LT Cortesia, and MT Ovid, which may have been avoided. It is a fact that the use of Ecdis safety settings is usually overlooked by navigating officers due to either inadequate knowledge or rush to issue the passage plan. Safety settings are very important for Ecdis display, as they control how the Ecdis presents depth information, making it easier to visualize areas of water that are safe for the vessel to navigate in from those which are not. And now, let's talk about the procedure in setting up Ecdis system. First, check primary position fixing system is set up correctly and prove that Ecdis is correct by inputting a manual fix into the system. Next, check system time is configured correctly. Ensure Ecdis setup is replicated on all Ecdis units. Ensure navigation tools are configured correctly. Next, ensure safety depth and safety contour settings are configured correctly. And next is ensure system units are configured correctly. And for the other procedures, I'll give the floor to Degamo.
Ensure that all relevant overlays are loaded. Ensure that areas are configured correctly. If system is used, allows alarm configuration. Number 3 is that ensure that docking mode is configured correctly. Ensure also that the navigation alarms are configured correctly, including safety, frame, or anti-grounding cone. Ensure that route alarms are configured correctly. Ensure also that the targets are configured correctly. Ensure that preferred radar is selected. Ensure that the vessel data is set up correctly. Ensure the audible alarms are working correctly. Next is that to ensure that chart motion, chart orientation, screen layout, color palette, and additional ENC setting are configured correctly. Ensure the correct display settings available for execution and navigation in accordance with Ecdis check of cards for pilotage and confined waters, and coastal navigation and open ocean. Ensure the correct route is loaded for route monitoring. Ensure that the correct waypoint and route monitoring information is being displayed.
Good day everyone, this is the Cadet Lozano Genesis John, and we're going to proceed to the Ecdis display configuration and setup. For all its potential, Ecdis is only computer software, running on a modernized PC. As a result, it suffers from all the faults and errors of any computer. The greatest single danger from Ecdis is to assume that it has been correctly configured with regard to the route, safety depth, safety counter, alarms, and displayed data. A ship can ground just as easily as a consequence of improper configuration as it could from sloppy chart work on a paper chart. For us to avoid any accidents due to any mishaps with regards to the faults and errors displayed on Ecdis, we have to check every data presented by the Ecdis. Where the Ecdis in use supports it, display configurations should be saved so that the system can set up quickly when transiting between different environments, such as confined waters, anchoring, coastal navigation, and open ocean. This will save time when setting up the system. Since we can save data on the Ecdis, we can use it to save time just using the displayed configuration being used during the previous voyages. Now, let's proceed to a more specified data with regards to the display setup of the Ecdis. First is the routes. Check. Ensure that the correct route is loaded for route monitoring. Action. Check that XTD has been set up to appropriate value. XTD means cross-track distance, which is the Ecdis safety parameter. Then, set up ETA, or estimated time of arrival, and set up the ETD, or the estimated time of departure. Confirm that the route has been checked, protect the route, activate the route for monitoring, and load the secondary route in Route Editor if required. As you can see, we can select this route tab to check the necessary data. So, secondly is the waypoint selection. Check. Ensure that the correct waypoint information is being displayed. Action. Check that the followings are configured correctly. Waypoint selection, auto or manual. Arrival circle, auto or manual. Radius, auto or manual. Track history on and set appropriate value. Secondary track on. Just like the route, there is also a tab here that we can select to check the data with regards to the waypoints. Third is the route display setup. Check. Ensure that the display is configured for route monitoring. Action. Configure the following parameters appropriately. First is the headline. Then, the COG vector or the course over ground vector. Then, the heading vector, shift by contour or symbol, aligned by the heading, course, leg, or speed on, XTD on, arrival circle off, radius on, waypoint names on. Next is the chart setup. Check and ensure that the chart is configured correctly. Action. Check that the following parameters are configured. Chart motion, relative or true. Configure look ahead if in true. Chart orientation, north up, head up, or course up. Chart auto load on. Chart auto scale on. Chart priority, electronic navigational chart. Now, let's proceed to the vessel setup. Check. Ensure that the vessel data is set up correctly. Action. Check that the followings are configured correctly. The ship position. Center on ship or displaced. Chart. Select the best scale chart available. Vectors 6 minutes. Set appropriate value. TCS ship condition. Loaded, medium or light. Configure as required. Here, we have to check if the vessel's data is exact, so that we cannot assume any faulty informations, especially with regards to our vessel. Now let's proceed to the select system units. Check ensure that the system units are configured correctly. Action. Set up system units for large distance, small distance, speed, depth, and time zone. In a tab here at the lower right corner, we can see the tabs to check the following informations about the system units. Now let's proceed to the layer setup. Check. Ensure that the chart is configured correctly. Action. Check that the display of layers is configured appropriately. Display category standard or custom or equivalent. Consider displaying the following layers: spot soundings, isolated dangers, names, cables, pipelines, voice name, other info, all depth counters, seabed, scale bar, and navtext. As you can see, these data and informations can be seen in a navigational chart. Now, it is necessary that we can also see this displayed on an Ecdis. For further discussion with regards to the Ecdis, my colleague Decadet Muñez will discuss more on the Ecdis display setup. That's all. Thank you.
Good day once again, this is Cadet Muñez, and I'm here to continue the report of my colleague Cadet Lozano about the procedures on the setup of the Ecdis display. So Lozano already discussed on the routes, waypoint selection, route display setup, chart setup, vessel setup, selection of system units, and the layer setup. So to continue with, here's the setup on the position source. You must check that the primary position fixing system is set up correctly. Action to be done is to check that Ecdis is correct by inputting a manual fix in the system. Select the best available sensor as the primary position source. Select the best available secondary position source. Check heading reading with Ecdis readout. Check log readings with Ecdis readout. Set SOG or STW as speed source and confirm that radar information overlay or RIO is available and prove Ecdis correct. Next is the time. You must check that the system time is configured correctly. As you can see in the picture, no, na ang time which is set correctly. Check that ship's time is correct in the Ecdis. Check that the correct time zone settings are applied. Okay, of course, as we travel through different countries, lahi ang time zone. Next is the radar. Ensure that the preferred radar is selected. Check that the RIO and ARPA targets can be displayed sa imo ang preferred radar nga di-select. Next is the overlay. You can see in the picture the overlay button. Check or ensure that all relevant overlays are loaded. Action to be taken is to check that the following overlays are loaded and configured. First is the manual corrections. Load file name as appropriate. Second is the additional information, which you need to load the file name as appropriate. And next is the targets. As you can see in the chart display, you can see a target there. To check or ensure that targets are configured correctly. Check that the following are configured correctly. ARPA contacts are on, vectors are turned on, tracks are turned off, AIS contacts is on, vectors is on, vectors are on rather, tracks off, and CPA alarm configure as necessary, and the TCPA alarm also you configure as necessary. Next is the main chart panel. So as you can see in the radar display, almost of the radar display screen is covered by the main chart panel. So You ensure that the main chart panel is configured correctly, of course. And the action to be taken is to check that an appropriate level of data is available for the execution of navigation. Check that the palette is configured to suit the condition. Check that the screen layout is appropriate for execution of navigation. Check that all relevant panels such as route data are open or available. And last two, route alarms. You must ensure that route alarms are configured correctly. Check that the following alarms are configured appropriately. The route alarm, the end of route alarm off, out of XTD alarm is on, out of schedule alarm configure as necessary. You must set the appropriate value for the WPT approach alarm. You must configure as necessary the off-leg course alarm. Off-leg course alarm on. Ecdis navigation aids. You must ensure that navigation aids are configured correctly. Check that the following are configured correctly. Protector is on. Configure as necessary. Manual fixing is available.
Functions of electronic chart display and information system are also known as Ecdis. Ecdis is a geographic information system used for nautical navigation. Many navigational aid systems have been digitalized as a result of advancements in electronic technology, and hybrid and autonomous ships have been achieved in advanced countries around the world. One of the most important functions of Ecdis is to aid with safe navigation and grounding avoidance. Ecdis features some functionalities that display not only chart information but also other data, as well as functions that alert the ship's navigator when a ship approaches or enters a potentially dangerous locations. And for more
And here are some navigational functions of electronic charts. It is to route planning, route monitoring, and route documentation. And with the similarity of the paper charts, this includes the ability to ensure that the route can be safely sailed by identifying navigational aids, marking position lines, and fixing the ship's position, then the correction of course and speed. And with the functions of electronic charts, it related to the basic settings like displays the category and highlight of danger. And for the navigational elements, example the on ship, the variable range marker, and the lines of position. And for the specific functions for route planning, and for the specific functions for route monitoring.
So now let's move on to the integration of Ecdis. So the purpose of Ecdis is to integrate discrete components into a single navigation, display, and control system. So Ecdis transition therefore involves a complex integration of that brings together AIS, gyro compass, radar, ARPA, echo sounder, wind sensors, display, and etc. So, and when taken as part of an overall integration, the entire bridge that consolidate must also account for NAMIA, Industrial Serial Interface, Ethernet, and communication. So, as we can see in the next slide, this is the diagram of the Ecdis and the components or the instrument that is integrated into it, like the ARPA, AIS, GPS, weather sensors, and many others. So next slide is the purpose of Ecdis is to replace paper charts altogether and make them obsolete. So Ecdis works in conjunction with rugged marine display and technologies including GPS or the Global Positioning System, and in compliance with the SOLAS Convention to enhance overall navigation safety procedure. So, since it is fitted with other equipments, Ecdis also incorporates the display information contained in other navigational publications such as tide tables and sailing direction, and incorporates additional maritime information such as radar information, weather, ice condition, and automatic vessel identification. So the AIS and the other functions of the equipment is combined into one system, which is the Ecdis. So Ecdis also provides redundancy and improves efficiency by avoiding duplication of words such as route entry and vessel systems. Integration of Ecdis with the vessel's communication system enables online communication from ship to shore for the exchange of data and reports, which helps us seafarer to be safer and more convenient when we go on board. So that's all for our report. Thank you.